Welcome back. My name is Luc de Koster, founder of the Koster Academy, and welcome to my YouTube channel. In case you didn't subscribe yet, don't forget to subscribe now. Click the subscribe button, click the bell button, and every time we have a new video, YouTube will inform you. In the previous video, we were looking at the application of the z-score, the first case. Now we're going to look at the second case. As you may remember, when I introduced the normal distribution, I described three different cases. We're going to try to find the surface between two values, between two x values or between two z values. Have a look at the standardized table type 1. So the first type of solution that we may have. And here you see that we want to find the surface between x1 and x2. And we do that by finding first the surface smaller than x2. So everything to the left of x2. And we subtract from this the surface smaller than x1. And the result of it is the surface between x1 and x2. Now, what we have to find here, we have to look at those two values. We have x1 and x2. We have the same distribution, so the average and the standard deviation in both cases are 90 and 15. The x1 is equal to 97 and x2 is equal to 107. And for both of them, I calculated the z value. So the z value is 97 minus 9 divided by 15, which gives us 0.467. And for the second value, x2, we have 107 minus 90 divided by 15, which gives us 1.133. Limited the z value to three numbers because here we have, in fact, a number which is between categories. We don't have it in the table, and what I'm going to introduce to you here is basically how to do the interpolation. First value, we have the standardized type. We want to find the surface for 0.467. We first find the row of 0.4. The value 0.467 is between 0.46 and 0.47, and we select those two columns. So basically what we find here is that for a z value equal to 0.46, we have a surface of 67.72%, and for 0.47, we have a surface of 0.6808 or 68.08%. So it means that for a difference of z value of 0.01, we have a difference of the surface which is equal to 0.36%. Based on this, we can find what is the difference that we have. The difference is 0.007. So basically we have to multiply the value, the surface, with 0.7, which gives us 0.7 times 0.36%, which gives us approximately 0.25%. So the surface that we find now, the surface to the left of z equals 0.467 is given by the surface for z equal to 0.46, which is 67.72%, plus the additional surface of 0.007 between z equal to 0.46 and 0.47. Now, when we have different values, this number will of course be different. The final result, what we have here, the outcome is that for z equal to 0.467, we have 67.72 plus 0.25%, which gives us 67.97%. Same thing for the other value. So we want to find the surface for 1.33. And we have here the first row for 1.1, all the numbers 1.1. And now we have to find the two numbers. We are between 1.13 and 1.14. So we select 1.13 and 1.14. And we repeat what we did in the previous slide. Basically, I see that for a Z value equal to 1.13, the surface is 87.08%. For a Z value of 1.14, the surface is 87.29%. And we see that for a difference of 0.01, the difference between 1.13 and 1.14, we have 0.21%. Now we only have 0.03, right, that we have to find. So basically we have to multiply the surface for the delta Z equal to 0.01 with 0.3, which with 0.21%, which gives us, for a delta Z equal to 0.003, we have a difference of the surface which is approximately 0.06%. I'm rounding it here to 2 decimals. More decimals have no significance in the exercises that we are going to do. So basically what I find for the Z value of 1.133, we find the surface which is equal to the surface corresponding up with Z equal to 1.13, which is 87.08%, plus the 0.03 additional Z value, which corresponds with 0.06%, and when we add those two, we find a total surface of 87.14%. Calculations done, we can put them in the table. So we find for x1 that the surface is 67.97%, for x2 it's 87.14, and we can now calculate the difference. So we take 87.14 minus 67.97, and we find that the surface between x1 and x2 is 19.17%. When we look at the table, so the graph here for x1, we find the surface of 67.97%. For x2, we find 87.14%, and we make the difference. The surface between x1 and x2 is equal to 19.17%. We can also use the standardized formula using the Z-score. So we put the numbers in there. We have the Z value that we calculated before. So we find the formula for x1 is norm S distribution 0.467 and true, which gives us again 67.97%. Do the same for x2, we find 87.14%. Basically, we find the same numbers that we had before, and now we find in fact the difference, and we find again 19.17%. Now it may be that in certain calculations, because we are doing a linear interpolation and the function is not really linear, so there are some small errors possible, that the numbers are not exactly the same than when you are using the Excel formulas or the formulas included in some other programs or calculators. But we see here, we use the formulas, the Excel formulas, and we find basically the same result. Now we do the same thing, but we use the X mu and the standard deviation. We find the same formulas. We have norm dist, 97, 90, 15, and true, and which gives us 67.97%. For x2 we find again 87.14%. We find the same end value, which is in fact a surface of 19.17%. So these are the elements that you can do, how you can do the calculation. In this slide you find some more calculations that you can practice on, and you can apply the different methods that I've shown you. Of course, today, thanks to the existence of all those computers and the specialized software, these calculations have become a lot easier, but you have to be careful. You have to understand what you're dealing with, how you do the calculation, in order to find the correct result. That was it for this video. Don't forget to click the subscribe button. Don't forget to click on the bell button. And of course, I'm looking forward to seeing you in our new video. Thank you and bye-bye.